Hey everyone, today we're going to see something on electrostatics. So in electrostatics, you have a derivation where you have an electric dipole. For example, here is an electric dipole, okay? So an electric dipole, basically an electric dipole has these two charges on both ends of opposite charge. So here is negative Q charge and here is positive Q charge. And you have these two charges. So there is a derivation on broadside on position, where you have to prove that any general point here on the equatorial plane, okay, from this electric dipole will have an electric field on this point. Effective electric field would be 1/4 pi epsilon naught times P by R square plus L square, okay, 3/2, and here this P basically means 2QL, which is we also know as the electric dipole moment, okay. So, and what is this R and this L? So this L is basically the length of this electric dipole, okay. So L is basically the length of one of the charges, the distance between one of the charges and the center of the dipole. So the total length will be 2L. And we take this total length as 2L for just simply some calculation, for making the calculation easier. And R is the actual perpendicular distance from the dipole to the point, to the general point P, okay, which lies on the central equatorial plane. So we'll see how this is true. So we'll just basically see the derivation of this very important physics. Okay, so this physics expression. So here we have a diagram. I have made this diagram here. So let me just show you what is basically I'm showing here. So let me just show you. So here we have an electric dipole. This is the point minus Q. Okay. So let me just change my image here. So I will just show you here. So here we have a negative Q charge and here a positive Q charge, and this is the electric dipole, okay, and this is the actual length here, which is 2L basically, and here we have an angle theta, okay. Now because these two lines are parallel, okay, this line is parallel to this one, so this basically means that by alternate interior angles we have these one as theta as well. And now we will see. So let us take this one as E1, okay, and this one as E2. So the electric field at point P. This is point P, okay, at the center, and this is the center here. Now the electric field on P due to the positive charge of the electric dipole is E1, and this is E2, or you can take either one, okay. So let's make this E2, and for the negative charge it is E1, okay. So as you can see, because we take at the point P we take a positive test charge. Now because it is positive test charge, this charge will repel it, okay, so it will go away from it. So it will go in a direction which is somewhat like this, okay. So I'm just showing you this direction, which looks somewhat like this, okay. It will go in this direction. All right, okay. So it will go in this direction. So this one is E1, and for the charge plus Q we have this direction. So this is basically E2 and this is E1. So if we see from trigonometry, we can see that this one is E1 cos theta and this one is E2 cos theta. As you can see very well, oh sorry, this is sine theta, okay. I'm just mistaking a bit here. These are sine components. So this is E1 sine theta and this is E2 sine theta, okay. Now very well you can see that these components, this one, okay, right here is both E1 and like E2 cos theta and E1 cos theta. So you can see they are adding up on this cos component, but they are cancelling each other on the sine component. So we can very well see that for E1 it would be 1 by 4 pi epsilon naught. The charge is q, so we are applying the laws and we are getting r square plus l square. Okay, E2 will also be the same because it's almost the same, and negative q charge doesn't matter here, so we'll not be using this sign here. 4 pi epsilon naught q, because the magnitude is the same, we're just using magnitude of the charge here. Okay, so we can very well see that E1 and E2 are basically same in magnitude, although their charges are different. Okay, but the magnitude of the charge is the same. So you can very well write that the E total, like total electric field at P, okay, would basically be E1 cos theta plus E2 cos theta. And also remember that this E1 sin theta and E2 sin theta, they cancel each other. The sine components cancel each other, okay, because they are opposite in direction, so they cancel each other. But these two, E1 cos theta and E2 cos theta, they add up, okay. So now because we know that E1 and E2 are equal in magnitude, we can replace either E1 or E2 with their counterpart. So replacing E2 with E1, so we have E1 here, and because there are two of these, so we have 2 E1 cos theta. Okay, so now we have 2 times 1 by, now write the value of E1, which is 1 by 4 pi epsilon naught times q by r square plus l square. Now let us find the value of cos theta. So okay, so we take this triangle, any of this triangle here. So let us draw this triangle here. Okay, now this is the positive q charge that is seen here, and this is the center of the dipole. So here we have theta, okay, and this is the r, and this is l, as I said earlier. So this one is r square plus l square. You can very well see that cos theta here will basically be equal to l by r square plus l square, because here this is the hypotenuse and this is the length. Okay, this is the base. Okay, compared to this angle. So we can very well write in place of cos theta here, we can write l by root r square plus l square. So you can see that it will be 2ql, okay, 4 pi epsilon naught, and r square plus l square 3 by 2. Now we know that 2ql is equal to P, okay, which is electric dipole moment. So your E eventually becomes 1 by 4 pi epsilon naught, okay, P by r square plus l square 3 by 2. Now how this is 3 by 2, okay? So see here, okay, at the below we have r square plus l square, whose power is 1, and with that we are multiplying a root. So the root basically means the power of half. Okay, so r square plus l square half. Now because it is multiplied, we just add up their powers. So r square plus l square to the power 1 plus 1 by 2, and you can see that very well adds up to 3 by 2. So r square plus l square, okay, 3 by 2. That's it. So this is how we prove it, and that's it. Thank you.